Hi everyone, we're solving this math paper today. This is 9709 paper 5-2, October November 2023. Paper 5, Probability and Statistics 1 S1. The time is 1 hour 15 minutes. You will be provided with the formula sheet where you get access to the normal distribution table, and all answers have to be given to correct to 3SF if non-exact, and to one decimal place for angles in degrees unless a different level of accuracy is mentioned in the question. Okay, you can also give answers in fractions. So guys, if you like the videos, please remember to subscribe to the channel, like the video, it helps with the algorithm a lot. Also share this with your friends if you think they might find this helpful. Also guys, if you require more help, you can consider supporting me on Patreon. I'll attach a link in the description. There are 3 tiers currently, one for general support, there's another one for access to one-on-one problem solving sessions over text on Patreon, and then you get access to all my solved papers from 2002 to 2023 for physics, chemistry, bio paper 1, 2, 4, and 5, and math P1, P3, M1, and S1, which is really helpful. You also get access to my notes for AS and A2 physics and chemistry, along with definition lists and ad-free videos. And for the highest tier, you get access to all those features plus one-on-one video meetings with me via Google Meet, solving your personal problems. So I'll attach a link in the description, and also remember to join the Discord channel. You can ask me for question paper requests there. I'll try to solve them as soon as possible. Yeah. Okay, so let's take a look at the threshold before we start. This is paper component 5.2. We have this over here. Now, out of 50, the full mark was 50. A was at 40, B 36, C 28, D 21, E at 40. Okay. So let's write this down. Out of the full mark 50, A was at 40, B was at 36, C was at 28, D was at 21, and E was at 14. So A star should be around, look at the mark difference. From C to B it's 8 marks, B to A it's 4 marks. It should be around 4 marks above this, maybe 43 or 44. That's the mark required for an A star. Okay, so without further ado, let's start. Okay, so a competitor is throwing, in a throwing event, has 3 attempts to throw a ball as far as possible. The random variable x denotes the number of throws that exceed 30 meters. Alright. Now, the probability distribution table for x is shown. Given that the expectation is 1.1, find the value of p and r. Okay, so this is how you do it. You know that the probability, the summation of the probability has to add up to 1. So we can say this 0.4 plus p plus r plus 0.15 is equal to 1. So we can actually write 0.55 plus p plus r is equal to 1, or 1 minus 0.55, which is 0.45. So p plus r is equal to 0.45. This is our equation number 1. Next, we also know the formula for expectation. We also know the formula for ex. So ex is equal to actually the sum of xp, right? Ex is the summation of xp. So we can actually write 0 times 0.4 plus 1 times p. It's better to show the working, plus 2 times r plus 3 times 0.15. Okay, I multiplied this and this. All the summation of those is actually equal to what did they say? 1.1, right? Okay. So now 0 plus p plus 2r plus what is this? 0.45 is equal to 1.1. So what do we end up with? 1.1 minus 0.45, that is 0.65. Okay. So p plus 2r is equal to 0.65. Now we can just use substitution. Okay, we can just use substitution. We know that p is equal to 0.45 minus r. So 0.45 minus r plus 2r is equal to 0.65. So r is equal to 0.65 minus 0.45, which is 0.20. That is one answer. And the other one, p is equal to 0.45 minus 0.20, which is 0.25. That is the value of p. So 0.25 and 0.20. Yes, okay. or you can just say 0.2. That's fine, anything works. Next, find the numerical value of variance. Okay, so we know that variance is actually equal to the summation of x square p minus expectation whole square. Okay, so let's do that. Variance of x is equal to summation of x square p minus expectation whole square. So x square p, so that is basically, 0 square times 0.4 plus 1 square times p, 1 square times p. Now we know the value of p, which is my value is 0.25, plus what is it, 2 square times r, 2 square times 0.2 plus 3 square times 0.15, 3 square times 0.15, that minus ex whole square. Okay, so if you solve this, 0 plus 0.25, 2 into 2 into 0.2, which is 0.8, plus 0.8, plus 9 into 0.15, that is 1.35. Oh, by the way, guys, I will be solving the other variants soon for S1, as well as P3, P1, and M1 for all the other papers for October, November 2023, this series, as well as May, June 2023. Hopefully before your May, June 24 session. Okay, so just subscribe to the channel so that you don't miss anything, right? Minus expectation whole square, which is 1.1 square, right? It was given in the question, 1.1. So minus 1.1 square. So let's see, 0.25 plus 0.8 plus 1.35, that is 2.4, minus 1.1 square. Okay, that gives me an answer of 1.19 exactly, 1.19 exactly, and that is our answer. Okay, moving on to the next one. Question 2. George has a fair 5-sided spinner with sides labeled 1, 2, 3, 4, and 5. He spins the spinner and notes the number on the side on which the spinner lands. Find the probability that it takes fewer than 7 spins for George to obtain 5. Okay, so what is this basically? This is a geometric distribution, because look at the wording. George has fair 5-sided spinner. Okay, a fair 5-sided spinner. So the probability for getting each of these is actually half. He spins the spinner and knows the number on the side on which the spinner lands. Now George needs to obtain a 5 to win. Okay, that's the basic distribution. So x is geometrically distributed, and the probability of success is getting a 5, which is half. Now we need George to win at fewer than 7. What does that mean? Px is less than 7. So George might either get it in the first try, second, third, fourth, fifth, or sixth, but not 7th onwards. Okay, so I always tell my students, I always show this, check this out. You need to have these memorized. Okay, so basically these are the formulas. Px is less than or equal to r equals to 1 minus q to the power r, and px is greater than r is equal to q to the power r. I'll explain the logic soon. So you'll see, if you have write this down when the exam starts. Okay, you need to write this down, and then you won't forget this, because this won't be given in the formula booklet. Yeah, okay, so let's match with this. Do we have x is less than or equal to r? We don't actually, we don't have that, so we need to convert that. Okay, so what does that mean? This is the same as px is less than or equal to 6. So what does that mean? George has obtained success within the 6th try, like first, second, third, fourth, fifth, or 6th, below the 7th or within the 6th. That means he has not failed there. He has not failed within the first 6 tries. So this can be written as 1 minus q to the power r, which is failure is sorry, I wrote 1 by 2 over here, my bad. It should be 1 by 5. Okay, I'm sorry, because you have the probability of success is 1 out of 5, my bad. Okay, so it should be 1 minus 1 by 5. Sorry, success is 1 by 5, so failure should be 4 by 5. 4 by 5 to the power r, which is 6. Now if you solve this, 1 minus 4 by 5 to the power 6, that gives you an answer of 0.738 rounded off to 3 significant figures. Okay, so that is how you do it. The formula for Px is less than or equal to 6 is 1 minus failure to the power 6. We just input the formula that I showed you over here, right? This. Now George spins the spinner 10 times. Find the so you have a fixed number of events now. So this is basically a binomial distribution. So y is binomially distributed n comma p. Now obtaining a 5 is still the success. Okay, so 10 throws, but success is still obtaining a 5, which is 1 out of 5 times. Now more than 4 but fewer than 8. What does that mean? Probability that we are going to get it more than 4 times. So more than 4 but fewer than 8. So what does that mean? Py is equal to more than 4, which is 5, 6 and 7, but fewer than 8. Okay, 5, 6 and 7. Oh, by the way, for part A, there was an alternate method. You could actually do it manually, literally manually. Like you could do P plus PQ square, first success, second, third, fourth, fifth, and sixth. Like manually, you could add the 6 ones. You would still get the same answer, but it's a lengthier process. Okay, so how do we do this? So we have 10C5, then success to the power 5, and failure to the power 5. Okay. Then we have 10C6, success to the power 6 and failure to the power 4. And finally we have 10C7, which is success to the power 7 and failure to the power 3. Okay. Now you actually need to show the working. You actually need to show the working, sadly, for the values that you obtain. Okay. So for example, that actually has a marking point. They said correct expression except unsimplified, no terms omitted. Okay, still show the working. So for this, you'll actually get 0.02642. What about that? 10C6 times 0.2 to the power 6 times 0.8 to the power 4. That is 5.505 into 10 power minus 3 plus 5.505 into 10 to the power minus 3 plus the last one, it is 7.864 times 10 to the power minus 4. After you add all of these up, you're getting a final answer as 0.0327. That is your final answer. Okay, so how did I figure out it's a binomial distribution? By looking at the fixed number of events. Success is still obtaining a 5, and we need more than 4 but fewer than 8. Okay, so that's how we do it. Number 3, factory produces a certain type of electrical component. It is known that 15% of the components produced are faulty. A random sample of 200 components is chosen. Use an approximation. Whenever you see approximation, you basically need to do the conversion. Since we have a fixed number of events, right, like 200 components, it's a binomial distribution, but it will be impossible to do it at such a large scale. So what's our job here? We will convert the binomial distribution to a normal distribution. Whenever you see the word approximation, that's what you need to do. Okay, so let's write down the binomial distribution first. X is binomially distributed. There are 200 components and the chance of being faulty is 0.15. Okay, now we need to find the probability that more than 40 are faulty. Okay, so we need to do this. Probability that more than 40 are faulty, but that will be impossible, right? 41, 42, 43, 44 and so on till 200. So what are we going to do? We are going to convert this to a normal distribution. How? We need the mean mu comma sigma square variance. We need the mean mu, which is np. That means mu is equal to 200 times 0.15, which is 200 times 0.15 is 30. And sigma square, which is variance, is npq, which is 30 times 0.85, yeah? 0.85 times 30, which is 25.5. So that's 30 comma 25.5. Fine. Now we have the normal distribution. We converted the binomial. We have approximated to normal distribution. Now we need to convert this to the normal distribution, this thing, but we need to apply the continuity correction. How do we do that? This is the trick. Okay, so suppose this is 40, this is 41, and this is 39. So it needs to be greater than 40. So 40 is not included. It is after 40. So to convert it to the normal distribution, you need to apply plus minus 0.5. So since 40 is not included, it will be from 40.5 onwards. not 39.5. If it was greater than or equal to 40, it would have been 39.5. But since it is greater than 40, it will be greater than 40.5. Okay, so now I change the letter p, p y. Okay, the normal distribution is py. You can say greater than or equal to, that doesn't really matter, it's fine. Greater than 40.5. We convert it to a normal distribution now. Okay, now let's solve it. Let's standardize it. Yeah, let's standardize it. How do we do that? Pz is greater than 40.5 minus mean, which is 30, divided by the standard deviation, which is root over 25.5. So 40.5 minus 30 divided by root over 25.5, which gives us a answer of, how much do we get? Pz is greater than, you will always put this to 3 dp, okay, 3 dp, or else you won't get the correct answer. 2.079 to 3 dp. Now I need to fix a few things. It is greater than, so what do we write? 1 equals to 1 minus pz is less than 2.079. okay, we do that. And then finally, what's the next step? Now we can find it from the table. So what can we just write? It is basically 1 minus phi of 2.079. So let's go have a look at the table. I'm looking for 2.079. 2.079. Okay, so 2.07 is over here. 2.07 below 7, right? 2.07 and 9, 1 2 3 4 6 7 9. 4 needs to be added to this last digit over here, so it turns into 12. 0.9812. I'm adding 4 to the 8, so 8 plus 4 is 12. 0.9812. So 0.9812. So 1 minus 0.9812, which gives us an answer of 0.0188. So that is the answer. Did they want the probability or number? No, just the probability. Okay, so that is our final answer. Hopefully that was clear for you guys. This was a sum on approximation. You will face this in your exam. It's a must. Okay, so how many questions do we have in this paper? We have a total of 7. Okay, we'll be done in 15 minutes, 15 to 20 minutes. Let's see how fast we can do it. I like making my videos concise. I don't like beating around the bush. I just want to give you the correct answer as fast as possible. Also remember, these question paper solving videos are not tutorials. Okay, so you can't expect to learn the whole thing by watching these videos. So you need to have a basic understanding of the syllabus, and just before the exam when you're solving papers, you can take a look at these. That will be easier for you guys to solve. Do you get what I mean? That's the basic understanding. Okay, so let's start. Back to back stem and leaf diagram. Okay, let's do that. Aces and jets. Okay, so suppose I put jets over here and aces over here. So the first thing is you need to look for the smallest value, which is clearly, I think, 160. Where is it? 164. And the highest value, which is 190, I guess, which is 190. Yeah. So based on this, you will be putting the stem. So the stem can have more than one digit. Okay, so it starts from 16. The stem starts from 16, 17, 18, and 190. Sorry, it's 19. Now let's start. So let's start for aces. Yeah, aces. So aces, we have 164. Always cut it down when you use it. 164. You have 168, 166, 6, 9, and 8. 166, 8, and 9. 166, 168, and 169. Okay, now for 170 we have 1713, 1, 3, and 4. We have 1, 3, and 4. For 180 we have 180, 1, 2, 2, 0. Oh, we had 0. So 180, 0, 1, 2, 2. 0, 1, 2, 2. Okay, fine. Now let's go to jets. For jets we have 190. We do have that, the highest value. we have 166, 6 and 8, 166 and 168. For 170, we have 170. Okay, so 0 4 4 5, 0 4 4 5, 0 4 4 5. And for 180, we have 1188, 1188, 1188. So let's check the mark scheme, see if it's fine. 1188, 0 4 4 5, 680, 4689, 134, and 0122. Fine, that's perfect. Now we need to input the key. A lot of students forget the key. So the key or the legend, basically you need to state what these actually mean. So they use this, alright? So we can write that 117 and 0. You could also use other things, other places. It's fine, okay? It doesn't really matter. So what does this mean? So it means 170. What are we representing? Heights, centimeters. So mean 170 centimeter for the aces and 171 centimeter. So 170 centimeter for the jets, right? So 170 centimeter for the jets, and 171 centimeter for the aces. That's what it means. Okay, find the median and interquartile range of the heights of the players in the aces. Fine. So aces, let's go for it. Median and interquartile range. Okay, so how many do they actually have? The aces, we have 11 players. So for 11, the median will be 11 plus 1 by 2, which is the sixth value. So this is how you do it. 1 2 3 4 5 sixth value. So the median is 173. That's how you do it. The sixth value, the median is 173 cm. And for the IQR, it will be the upper quartile Q3 minus Q1. So let's see how to do it. So basically, if it's an odd number, you basically isolate the middle value. So I'm getting rid of 173. Now since there are 11 numbers, how can it be divided? 5 values here, 1 value in the middle, and 5 values on the right. Okay. So I have isolated the middle value. Now there are 5 on each side. So Q1 will be the middle value of the first 5, and Q3 will be the middle value of the second 5, the latter 5. Okay, now what is the middle value of 5? It is going to be 5 plus 1 by 2 again, since it's an odd number. So 6 by 2, which is the third value. So 1 2 3, this is the third value, 168. That is Q1. And for this one, 1 2 3, the third value of these 5 values, 181. So that is 181 minus 168, which is 13 centimeters. Okay, 13 centimeters is our answer. That is the IQR, and we have the median. Hopefully that was clear. Give one comments comparing the spread of the heights of the aces with the spread of the heights of the jets. Okay, so you can talk about the range. So let's talk about the range for jets. Check this out. For jets, the range is 190 uh, 190 minus 166, which is basically 24. And for aces, what is it? 182 minus 164. How much is that? 12 plus 6, 18. So basically, jets have a more spread out heights. Okay, it's more spread out, wider range. So let's write that down. That is one comment. Jets have a wider range of height. Jets have a wider range of height. Then you could also find out the IQR for jets. But yeah, in general, jets have a wider range of height. The alternate way of saying this one was jets have a greater variety of heights. Jets have a greater variety of heights. Same thing, by the way. Then jets have a wider spread of heights, or aces have a smaller variety of heights. Same thing. Aces have a smaller variety of height. Okay, so yeah, that is all. You don't need anything else. That's it. The heights of the members of a club are normally distributed with mean 166 and standard deviation 10 cm. Now find the probability that a randomly chosen member has a height less than 170. Okay, so X is normally distributed with a mean of 166 and a standard deviation of 10, so 10 square. Now we need a height of less than 170. So let's go for the standardize this. PZ is less than 170 minus 166 by 10. Where's my calculator here? 170 minus 166 by 10, which is 0.4. So PZ is less than 0.4. Now you can write this as phi of 0.4 basically. So let's look for 0.4. 0.4. So it's 0.6554. 0.6554. 0.6554. That is all. But you need to give your final answer to 3SF. Always remember that, okay? They did accept that, but please round it off to 3SF. Now, given that 40% of the members have heights greater than 8 centimeter, find the value of h. So Px is greater than h, more than 8 centimeter, right? So greater than h is equal to 40% or 0.40. So let's standardize this. So how do you standardize that? Is basically Pz is greater than h minus 166 by 10 is equal to 0.40, or 1 minus Pz is less than h minus 166 by 10 is equal to 0.40, and finally Pz is less than h minus 166 by 10 is equal to 0.60. So this is the inverse. So we are looking for 0.60 in the table, 0.60 in the table. Look for 0.60. If you can't find 0.60, find the value that is closest to it. So this is the closest value to 0.60, and the gap from 0.60 is merely 13. Okay, I'm looking for 13 because 13 plus 0.5987 0.0013 is actually 0.6. So I look for 13 over here, but I don't get 13. So the closest value to 13 is 12, which is why I will opt for 0.253. 0.253. 0.253. Okay, so h minus 166 by 10 is equal to 0.253. 0.253 times 10 plus 166 is 168.53. H is 168.53 centimeters. Okay, you could round this off, but it's fine since we get an exact answer here. Now, what do we have? The random variable x is normally distributed with mean mu and standard deviation sigma. So it's x over here. X is normally distributed with mean mu and sigma. Given that sigma is equal to 2 by 3 mu, find the probability that randomly chosen value of x is positive. So being positive means x is greater than 0. Okay, so let's standardize this. This is the same as Pz is greater than 0 minus mu divided by sigma. Then we can just apply some substitution. Z is greater than minus mu divided by 2 by 3 mu. Now we can get rid of the mu's easily. We can get rid of mu. So that is Pz is greater than minus 3 by 2 or 1.5. Okay, so this is Pz is greater than minus 1.5. Okay, now we need to fix things. Okay, the greater than and minus sign, we need to fix it. How? So the first step is 1 minus Pz is less than 1.5 minus 1.5. Then the next step is 1 minus, also to fix the greater than and minus sign, you have to apply a 1 minus. Okay, do you not want to know why? It's basically, look at the graphical representation. So this is basically minus 1.5. So I am asked to find out this region over here. So according to symmetry, it will be the same as this region, which is P Z is greater than 1.5. But we can't find that directly, so what do we have to do? We have to apply 1 minus Pz is less than 1.5. Why? Because in the table, in the normal distribution table, it is only for less than values. Like you can go behind, not forwards. So what we do is essentially we are going to find out this blue region and then subtract from 1 to find out the small red region over there. Okay, so to fix this, I apply this again, 1 minus P Z is less than 1.5. I got rid of the minus sign as well as the greater than sign. Now it's 1 minus 1 plus P. Z is less than 1.5. We can get rid of these. So P Z is less than 1.5. Let's look for that. 1.5 is 0.9332. Orange. 0.9332. You should run it off to 0.933 as your final answer. Okay, hopefully that is fine for you guys. We are done with questions 1 to 5. Now let's move on to the last two, question 6 and 7. Okay, we won't take long, maybe 10 more minutes. So let's see. Let's see how to do it. Okay, so bag X contains 7 red marbles and 3 blue marbles. Bag Y contains 4 red marbles and 1 blue marble. Freddy chooses one of the bags at random. Our marble is removed at random from that bag and not replaced. Okay, so no replacement. A new red marble is now added to each bag. A second marble is then removed at random from the same bag that the first marble had been removed from. Draw a tree diagram to represent this information, showing the probability of each of the branches. Sounds a bit complicated, but it's doable. Okay, we can do this. So let's start. So the first one is whether we are picking a marble from, well, let me give another color, it will be easier for you to understand. Red and blue, right? Okay, so we will either pick from bag X or bag Y. Bag X or bag Y. Okay, so the first probability is choosing from bag X and the other one is from bag Y. So there's equal probability of choosing one of the bags, right? Freddy chooses one bag at random because we have two bags. So the probability of selecting each will be half. Either you choose bag X or you choose bag Y. Okay, so what's next? Now let's start with bag Y. There are 10 marbles in total. Okay, so the probability of choosing a blue one is 3 by 10 and a red one is 7 by 10. Okay, so 7 by 10 for the red marble, 7 by 10 for the red marble, and 3 by 10, it's 3 by 10 for the blue marble. And now it is not replaced. Okay, now a new red marble is added to each bag and then a second marble is chosen from the same bag. Okay, so for example, you had 10 marbles but you took one away, right? Now you have 9 marbles, right? But then you add another marble, so we are back to 10 again. So the total doesn't change, you will always have 10. But after you take the red marble, you have another chance to take another red marble or a blue marble. Similarly, you can take a red marble from here or another blue marble. Now the number of blue marbles will keep on decreasing. Do you get what I mean? Suppose if you've taken one blue marble here, the number will reduce to 2, but the total will still remain at 10 because you added another red marble, not a blue one though. Red was added, not blue. Okay. But here, you did not take a red marble in the first place, so there were still 7. Now you added 1, so you have 8 red marbles now. Okay, that's the logic behind this. Okay, let me just draw this over here. Red, red, blue, blue. It will be 2 by 10 here, and it will be 8 by 10 here. Now here on top, you've taken one red marble. So the number of red marble has decreased to 6. But then you add another red marble, so it returns to 7 by 10. And it will still remain at 3 by 10 over here. Does that make sense? Now that's for bag X. Now for bag Y, let's start doing it. So at first, we either take a red marble or a blue marble like this. And then we take another red marble or a blue marble. Same story. Over here we also have red marble followed by blue marble. Okay, so in bag Y, what was the situation? 4 red marbles and 1 blue marble. 4 red and 1 blue. Okay, so 4 red marbles, which is, so in total 5. 4 by 5, and blue is going to be 1 by 5. Now if you've taken the red marble and then you want another one, so what will happen? The one you've taken will be replaced by another red marble. It will still remain at 4 by 5, and this will be 1 by 5. Now for this one, Like if you've taken, if you've taken the blue marble, you have none. You have no blue marbles remaining. So the probability is actually 0. You don't have any blue marbles remaining. Now all you have is 5 red marbles. So the probability will be 1 or 5 by 5. That's what they wrote in the mark scheme. But you could write 1 because you have only red marbles left. So the probability of choosing the red marble is 1. Because you've taken one blue marble away, they are not replaced. But you add another red marble. So you have 4 plus 1, 5 out of 5 red marbles now. Okay, so this is the tree diagram. Hopefully I could clarify. Find the probability that both of the marbles removed from the bag are the same color. Okay, so we could go for red red, blue blue, or a red red for bag Y, but there's no blue blue for bag Y because you actually end up with no more blue marbles in the second one. That's why you can't go for blue blue in the second one. Okay, so let's start. Same color, right? So probability that both are same color, both same color. So what does this mean? You can either get both blue or both red. Now both blue is only possible from bag X. From bag X both blue, but not Y. And for double red you can get double red from X as well as double red from Y. Fine. So let's begin. Let's just look at the tree diagram. Double blue from bag X. 3 by 10 times 2 by 10. I'm just following the blue path. 3 by 10 times 2 by 10. Double blue. But you need to take one thing into consideration. This half as well. Because we are choosing from bag X in the first place. Right? Okay. So it's going to be half times 3 by 10 times 2 by 10. Next, again, half times double red is 7 by 10 times 7 by 10, which is 7 by 10 whole square. 7 by 10 times 7 by 10. And for Y double red, half times 4 by 5 times 4 by 5. 4 by 5 times 4 by 5. Okay, okay. So what is this? 0.5 times 3 times 2 by 100. That is 3 by 100. 3 by 100 plus 7 into 7 by 200, which is 49 by 200. And then 0.5 into 4 by 5 into 4 by 5, which is 8 by 25. Now if you add all of these up, 49 by 200, you actually get an answer of 0.595. 0.595. That is your final answer, 0.595. Perfect. Okay. Find the probability that bag Y is chosen given that marbles are not removed. Marbles removed are not both the same color. Okay. So this is conditional probability. So this is the success. Probability that bag Y is chosen, and this is the condition. Given that, always look for given that marbles removed are not both the same color. So we have the probability of having both the same color. So what will the different color be? Okay, just 1 minus the answer from the top. So basically it's going to be P probability that not both same colors, okay, is going to be 1 minus 0.595. Let's do this. It's so that is 1 minus answer, which is 81. 81 by 200. Okay, so now let's write down the conditional probability. Okay, so the probability will be like this. We are choosing from bag Y, and the condition is different colors. Okay, not both same color means different colors, same thing. Okay, different colors, they can't be the same color basically. Okay, all right, so the condition will always go on the bottom. So 81 by 200 is on the bottom, but now I will take from bag Y but with different colors. Okay, so what are the roots? Bag Y, I can take red followed by blue, or bag Y blue followed by red. So those are the probabilities. Okay, so I think let's go for it. Come on. Okay, so half into red, 4 by 5 times 1 by 5. Okay, so there has to be an intersection between bag Y and different colors. That's what I'm doing right now. So half times red then blue, 4 by 5 times 1 by 5. 4 by 5 times 1 by 5. This is YRB plus bag Y again, but this time BR. Why BR? Half into 1 by 5 into 5 by 5. 1 by 5 into 5 by 5, which is 1 basically. 1 by 5 into 5 by 5. So 0.5 times 4 by 5 times 0.2, 2 by 25, plus 0.2 into 0.5, 1 by 10, by 81 by 200. Okay, divided by 81 by 200, which is 4 by 9. 4 by 9 is my final answer, and yes, that is the correct answer, mark scheme answer. Okay, fine. We are at the end now. I'll just finish in 5 minutes. Okay, it's a permutation combination. We have Andromeda, 9 letters. So whenever you get a word like this, always split the letters like this. Andromeda has double A, double D, and it has N-R-O-M-E, N-Rome, N-R-O-M-E, double D, and double A. 9 letters in total. Now, we need the number of arrangements in which no consonant is next to another consonant. So what are the consonants here? Double A, O and E, these are vowels, and double D, N, R, M, these are consonants. So these consonants cannot be next to each other. So whenever you get this type of sum, you have to apply the arrow method. Think of it without the consonants because they need to be kept separate. So just put in the vowels first, A, O, E. So for A, O, E, what will be the number of arrangements? 4 factorial by 2 factorial, because 2 A's are repeating. And now where can the consonants sit? They can sit in these arrows. They can't sit next to each other, but they can sit in these arrows over here. So 5 spots and 5 consonants, so that is 5p5. 5 spots, 5 consonants, 5p5. But since there are double D's which are repeating, we need to divide that by 2 factorial. So our final answer is 720. And 5p5 is the same as 5 factorial. Okay, guys, it's the same thing. 5p5 means 5 consonants, 5 spots. Okay, 720 is our answer. Let's move on to the next one. Find the number of different arrangements of the 9 letters in the word Andromeda in which there is an A at each end and the D's are not together. Okay, so I'll teach you how to do this. This is what I prefer. So since the D's are not together, I will think of this arrangement without the D's. I only have double A and N Rome currently. So how many letters is that? 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. Now the A's will be at the two ends. The A's will be at the two ends, and I will do nothing with them anymore. I just put them there and I ignore them completely because they are not different letters, they're the same thing. So it's going to be 2 factorial divided by 2 factorial. I ignore it completely. Okay, now we can put in N Rome, N R O M E. So for N Rome, since all of them are unique, it will just be 5 factorial. Since all of them are unique, it will just be 5 factorial. Okay, for N Rome. Now what about the D's? Now I will think about the D's. Okay, so where do we put them? That sounded wrong, by the way. So we can put them here, 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 and here, but they can't be at the ends. Okay, they can't be next to each other, but they can't be at the ends either because the A's have taken those spots. So how many spots do we have? 1, 2, 3, 4, 5, and 6. So 6 spots, so that's 6p2 divided by 2 factorial. Or you could write this as same thing, 5 factorial times 6c2, because the D's are, because the D's are the same thing. So you could either write 6p2 by 2 factorial, or you could just write 6c2. It's the same thing, and you will get an answer of 1800. Hopefully that makes sense. I actually prefer this. There is another route to do this though. I'll teach you. Basically what you can do is, you can keep the D's together and then subtract from the total arrangements where the A's are at the ends. Okay, so I'll teach you how to do this. So keep the A's at the ends, and 1, 2, 3, 4, 5, 6, 7. So N Rome and double D. So A's are at the ends. Now we have 7 letters in the middle, so 7 factorial by 2 factorial. That is all possible arrangements with A's at the ends. Now I'm going to put the D's together. Okay, so the two D's will be 1 unit, and we have N R O M E. So how many units in total in the middle? 6 factorial. And for the D's, 2 factorial by 2 factorial. It cancels out. So if you subtract 6 factorial from 7 factorial by 2 factorial, you will still get the same answer of 1800. I don't prefer this personally, but this is also doable. I prefer the arrow method. Okay, so this is a pretty common type of sum, so you need to be able to do this properly. Yeah. Moving on to the last one. 4 letters are selected at random from the 9 letters in the word Andromeda. So we are choosing 4 letters. Find the probability that this selection contains at least one D and exactly one A. So look at this setup, A and D, at least one D and exactly one A. So we need one A and at least one D. We have two Ds available, so that is either you'll have one D and one A or two Ds and one A. Okay, one A, we need one A, and either we need one D or two Ds, because at least one D is required. Okay, so now let's take a look at this. This sum has only been there 3 times. This is the third time in A2. I've never seen this before except those 3 times. So basically, how do you solve this? Whenever you see the word probability, usually the question that you face is find out the number of selections. Okay, but since this is probability, repetition does matter. Having more than one letter does matter because it's probability. Suppose you have more red marbles in a bag. Although it's the same red marble, aren't you more likely to pick a red marble rather than a blue one, like the previous question? So yes, here, since it's probability, having more matters. Okay, so since I'm taking 4 letters, I have 4 blanks, 1 2 3 4, and the possible combinations are 1A 1D or 1A and 2Ds. Now the other blanks can be filled up by any letter from n row. Okay, so since there are 5 letters from n row 5 and I have 2 blanks, it's going to be 5C2, and in this one it's going to be 5C1. So if they asked for the number of selections, it would just have been 5C2 plus 5C1. That's the end result, that's the answer. However, this is a bit different. Okay, it's just not 5C2 and 5C1, since probability matters. Like, we could pick one A out of these two A's. That is why I'm adding this 2C1. We could pick one D out of these two D's, which is why I'm writing 2C1, because we are more likely to pick a D, right? Because we have more options. Similarly, I can pick one A out of these two A's, so that's 2C1, and there's only one way to pick two D's from two D's, which is why I have 2C2. So although these combinations are not unique, these are all the possibilities in which we can have this setup of 1A 1D and 1A 2Ds. There are 50 ways to do that. So that's how I find out the probability. You can find this question in like 2 other sums in 2021 and 2022 respectively. You will look for this word. Like, there are letters that are going to be selected, but they will ask for probability. In that case, you have to add this extra green part, okay, for each extra letter that you have. So since this is a probability, this is success, 50 is the success, and below we are just going to select any 4 letters from the 9 letters. So that's 9C4, and the final probability is 25 by 63. 25 by 63, and that is our final answer. Okay, so hopefully guys, I was able to clarify your problems. That is the end of the paper. I think it was pretty easy, not a really hard paper. 40 is fine for A, 44, 45 should be enough for an A star. If you do have any other confusions or other requests, please do comment below, like the video, share the video with your friends. Also, quick shout out to my top tier patron for the month. As usual, we have Dewa from Indonesia. If you guys want to be featured at the end screen for all my other videos, please do consider supporting me on Patreon for the highest tier, where you get access to one-on-one video meetings with me. Also, when I'm done solving them, I will link the paper for 9709 paper 5.1 up top, and the paper for 9709 paper 5.3 down here, and I'll link the playlist for S1 over here. And remember to hit the subscribe button. See you guys, bye bye.